Hi guys, I am Ahmed Rifai and I'm going to show you how to graph square root functions. Square root functions. Does this curve, which is formed when you throw the basketball, form a square root function? I don't know. Does this curve, which is formed when you slide your car right, form a square root function? I don't know. Okay, to know, let's start our lesson. In this lesson we have main points. 1. Finding the domain of the square root function. 2. Graphing the square root function. 3. Graphing vertical translation. 4. Graphing horizontal translation. First, finding the domain of the square root function. What does it mean, domain? The domain, it means all of the values of x that make the radicand is equal to or greater than 0. Find the domain and the range of each function. The first function here is y equal root x plus 12. How to get the domain and the range at this time? We have to take the value of the radicand and form an inequality more than or equal to 0. So at this time, what are the values of x that make this inequality happen? Yes, all of the values which started from 0 and up. So this is the domain. So the domain is started by 0 and all of the positive numbers which is greater than 0 until infinity. And 0 is closed, positive infinity is open. So this is the domain. How to get the range? To get the range, just substitute with the first value of x here, which is 0. So here, root 0 plus 12 equal 12. So the range is all of the values which started by 12 and move up to positive infinity also. And the 12 it will be close and positive infinity up. Now the second equation here, y equal root 2x minus 3. How to get the domain and how to get the range? By the same way. 2x minus 3 more than or equal to 0. So here add 3 to each side. Cancel. So 2x more than 3. Divide each side with 2. So x here is more than or equal 3 over 2. So this is the domain. The domain is started by the values of x which is equal to 3 over 2. So the domain equal 3 over 2 and it's close until the positive infinity. Now how to get the range? Just replace at the function. So y equal 2 times 3 over 2 minus 3, which is equal to 0. So the range here, it's started by 0 until the positive infinity. So it's close 0, open positive infinity. For this example, I will let you to solve this question. Now, second part of the lesson, graphing the square root function. What is the graph of y equal root 2x? To graph any function, we have 3 steps. The first step is, number 1 here, we have to get the domain of the function. So 2x more than or equal to 0. Divide each side by 2. So x is more than or equal to 0. So the domain is started by 0 and all of the positive integers, or all of the positive numbers. Okay, so this is number 1. Number 2, we have to choose here values for x and y. But don't forget here, the first value, it has to be the first value at the domain. So here, 0. And after that, you can choose any number, like 1, 2, 3, any number. But here, because of this radicand, So we can choose number that make this radicand, this number is perfect square. For example, here we can choose 2, because 2 times 2 will be 4, so root 4 is 2. After that we can choose 8, because 2 times 8 will be 16, and root 16 is 4. So this is the second step. The third step is to graph right now. So here this is 0. So how to graph? Just to plot the points. The first one is 0 and 0. The second one is 2 and 2, so from 2 move up to 2. The third one is 8 and 4, so from 8 move up to 4, by this way. Then start to join these points. So here we're going to join these points by this way. So this is a graph of this function. Okay, here there is a note. The domain tells you the limits of values of x, and we can use the domain to find the range. The domain and the range of a function tell you where to start the graph of a square root function. Parent square root function. The parent square root function is a function in this form: y equal root x, and it's called parent because it's the original form. Okay, so this form y equal root x is called parent square root function, and this is the graph. So this curve is the graph of the parent square root function. What's the benefit of it? Look, we can use the rules of transformation to graph any other square root function using the parent square root function. For example, look, we can move it down. Just this curve, we can move it down. Also, we can move it up, right, left, and so on. So all of these functions, all of the square root functions have the same curve, but just you have to move it up or down or left or right. Okay, so because of that, we call this function as parent square root function. Number 3, graphing vertical translation. Here, to graph any vertical translation, you have to know the standard form or the general formula of the square root function, which is y equal a times root x minus h plus k. So this is h, this is k, and this is a. We have 3 values here, and all of this formula is called the original formula of the square root function. And according to these numbers a, h, and k, we can graph the square root function. Here, if k is negative, so just shift the function down. But if k is positive, shift the function up. So according to the value of k, this one, which is out the radical, if it's negative, so shift the function down. If it's a positive, shift the function up. For example, here this is a parent function. Okay, what if we have this question, y equal root x minus 3? He said graph it. Just here you have to look for the value of x. Sorry, the value of k. The value of k here is negative value. Okay, so because it's negative, so we have to move it down 3 units. So it's a graph, it will be by this way. Look here, so it started from negative 3 down. So this curve is exactly the same as this one, but here it started from negative 3. So because of k here, we tried to move this curve down 3 units. So this curve is the same as this one exactly, but here it started from negative 3. Number 4, Graphing horizontal translation. Also, you have to look for the same formula, which is y equal a root x minus h plus k. The horizontal graphing here, it depends on the value of h. If h here negative sign, if it's negative like this one, so here you have to shift right or translate right. But if h is positive, so translate left. So translate left. For example, here this is the parent square root function, y equal root x. So all of them depend on this one. Okay, and we have this example, y equal root x plus 3. How to graph it? Here we have to look for the value of h at this time. Why h? Because this number, it's under the radical, and this is with x. So this number is called h. H here is positive, so at this time you have to shift left. Okay, so it's a graph. It has to start from negative 3, so it's by this way. So this curve, the new one, is exactly the same as the previous one, but it started from negative 3. Okay, so do not forget again, here to graph horizontal, it depends on the value of h. And h here is positive. If it's positive, so shift left as this number of units. If it's a 4, so from negative 4. If it's not 5, so start from negative 5. But if it's negative 3, yes, if it's negative, so shift right. So start from 3. If it's negative 4, start from 4. It means it starts from the opposite. Okay? Okay. Now in general, all of these functions depend on a, h, and k. What the importance here of a? Yes, a show that the function reflected on x or not. If a is positive, so it's in this form. But if a is negative, so it will be from down by this way. Okay. Now we have this example. He said here y equal root x plus 1 minus 3. So at this time we have two translations, one horizontal and one vertical. So you have to determine h and k. Yes, correct. Here h is positive 1, and here k, so h is positive 1 and k is negative 3. What does it mean? Yes, look here again. If h is negative, yes, good, translate right. But if h is positive, so translate left. So here we have to start from negative 1. This is number 1. Okay, number 2. You have to shift here up or down according to the value of k. K here is negative. Okay, if k is negative, so shift down. So from negative 1, move down to negative 3. So our graph, it will start from this point. Okay? Okay, so here we have to start our graph from negative 1 and the negative 3. It will be by this way. Finally, you have to check understanding. Number 1, finding the domain of the square root. Number 2, graphing the square root. Number 3 and 4, graphing vertical translation, graphing horizontal translation. By the end, with my best wishes, Mr. Ahmed Rifai. Please do not forget to subscribe and like and share. Thank you for listening. See you soon.